So in the previous tutorial, we have discussed about singly linked list. In this tutorial, we are going to learn about doubly linked list, and we know that singly linked list is just a collection of nodes, and they are connected using the pointers. And since we are using a single pointer here, which we were calling at we are calling this pointer as the next pointer because it is pointing to the next node or the next data. So this is an example of a singly linked list. So let's see what is doubly linked list. I'm going to draw a visual explanation or a visual diagram of the doubly linked list so that you will be able to understand why doubly linked list is much more better than a singly linked list. So in a doubly linked list, we have nodes that contain data. Let's suppose these are the nodes, and let us take an example of four data elements. Let's take an example of four integers like 3, 5, 8 and 12. So let me fill in the data here. 3, 5, 8 and 12. So we know that in a singly linked list we were using a next pointer to point to the next node. In doubly linked list we are going to use the same ideology. We will also create a next pointer that points to the next element of our data structure. And we know that the last next pointer points to the null value. So this is a next pointer. So the advancement in doubly linked list is that now we are going to maintain another pointer which is known as the previous pointer. So we are going to maintain a previous pointer here, and the previous pointer points to the previous element of the doubly linked list. And we are using two pointers. We are maintaining two pointers. One is the next pointer and another one is the previous pointer. And since we are using two pointers, that's the main reason why it is known as doubly linked list. So we are going to maintain two pointers in our linked list. And as usual, since the next pointer is also pointing to null, our previous pointer will also point to a null value. And similar to the singly linked list, we also have the first structure as the head structure, or you can say the first node is known as the head, and we are going to traverse through this linked list using the reference to the head pointer. The main reason why we are using a doubly linked list is because the flow of traversal in singly linked list is unidirectional. So I'm going to write here unidirectional. But in case of a doubly linked list, you can even traverse backwards, so it is bidirectional. So if you want to print your data structure in a reverse order, let's suppose I want to print out this whole linked list in a reverse direction, I will just use previous pointers and I will display the elements of the node. So that's the main reason why we are using doubly linked list, and we can traverse in the reverse direction. But in case of singly linked list, you cannot there is no way to just traverse backwards. So traversal in the backward order is not possible in a singly linked list, but it is possible in a doubly linked list. So in the implementation part, so when we will implement doubly linked list, we are going to create functions, and we will create the functions in the next tutorial, but here I'm going to just discuss about what the functions will do. So the first function that we are going to create is a get new node function, and this function is used to return. It will first create a node, or particularly a new node. So this function, we are going to pass some data to this function, and this function will create a new node using the malloc function, and then it will return a reference. It will return a reference to that node. So this is the first function that we are going to implement. The second function that we are going to implement is insert at tail. And this function insert at tail will take some data. Let's suppose 8 is the data, and this function insert at tail will insert a new node at the tail of our linked list. So this is the head of our linked list, and this is the tail of our linked list. So if you want to add some element at the tail of our linked list, this function will traverse. It will traverse throughout the linked list. It will traverse through our linked list using a while loop. And whenever the last pointer becomes null, it is going to insert the data at the last position. The next function that we are going to implement is insert at head, and it is a simple function. Let's suppose we want to add 13 at the head. That means we want to add 13 here. So to add 13 at this position, we will have to remove this null pointer. We will have to point this to the node, and then we will point it to null. So insert at head will we don't need to traverse to the linked list, because we are going to add the new element at the starting of the linked list. So insert at head inserts element at head, and in this function we are going to just manipulate the function, manipulate the pointers, and these pointers, we will have to change the pointers here, and after changing the pointers we will get a doubly linked list like this. We will have to create a next pointer and a previous pointer also. So in the implementation, the structure will have 3 variables instead of 2. So our structure will have 3 variables. One is the data, then a next pointer, and then a previous pointer. Remember that these both are simple pointers, but they are referencing to different elements. Next pointer is used to reference to the next element, and the previous pointer will refer to the previous element, and we will implement that in using these functions. So the fourth function that we are going to implement is the print function, and this function is used to display our linked list, display doubly linked list. So I'm going to write here in the short form DLL. And the last function is the reverse print function, and this function will make use of the the previous pointer, and it will use the previous pointer to traverse in the backward direction, and it will print our doubly linked list in reverse order. So this is the main use of doubly linked list. Reversing, you can just display your doubly linked list in the reverse order, which was not possible in our singly linked list. So in the next tutorial we are going to implement these 5 functions one by one, and we will see how we can use doubly linked list to display the data elements in the reversal, or you can say in the reverse order. So thanks for watching.